Okay, this is on page number 155. And this is from review exercise 6. Okay, in the first part, it says by sketching a suitable pair of graphs, show that this equation is exactly one real root, okay? So for that sketch, you need to bring a y in here, okay? You bring a y in here. So we have two equations, y equal to e raised to power 2x plus 1, and then you have y is equal to 14 minus x cubed, okay? Now, generally, if we like do some rough work here, your e raised to power x graph is like this, and your x cube graph is going to be like this. This is a bad sketch here. This is going to be like this, okay? And come on, yaar. So you have something like this, a graph like this, okay? And if it is minus x cubed, so you must know that minus x cubed graph is like this. Okay? So just ignore this 2x plus 1 for a minute here. Okay, so this is your e raised to 2x plus 1 graph. When you have 0 here, this value is going to be e here. So just mention this is e. Normally, when you have 0 here, when it is simply e raised per x, you have 1 over here, okay? And then you draw the other graph here. That is, now if this is just y is equal to minus x cubed, so this has to be like this. And if you add 14 into it, so that means this intercept is going to be now 14, okay? So I'm just going to keep 14 somewhere here, okay? And this is just going to be out of scale, but this e is 2 point something, and this is going to be 14 here. Okay, so just a little dotted line here, just to show that the graph has been switched. Okay, so here is this minus x cubed. So the sketch is going to be like this. Okay. So got it? These two graphs, they are intersecting just once here. So that means this equation, which was e raised to power 2x plus 1, that is equal to 14 minus x cubed, it has just one real root, okay? It says show by calculation that the root lies between 0.5 and 1. So we have to show in the second part, this was the first part here where you had shown the sketches. In the second part, we have to show that this x, this root is between 0.5 and 1. This is between 0.5 and 1. So you must remember that for that purpose, you need to bring all the terms on one side. This is e raised to 2x plus 1 and plus x cubed, then minus 14, and that is equal to 0. And then you name this as f of x. Okay, guys, get your calculators ready. You tell me what is f of 0.5, and then you tell me what is f of 1. So we see that once we get these two values, so this is negative and this one is positive. So we have, through the calculation, shown that the root really lies between 0.5 and 1. Okay, so you must write here that the change of signs suggests that the root lies between 0.5 and 1. Okay, now we move to the C part now. In the C part, it says, show that this root also satisfies the equation. So this is a bit of algebra involved here. This is ln 14 minus x squared, x cubed, sorry, this is 14 minus x cubed minus 1 over 2. If you remember, I have told you that in this part, this is basically a process where you make that iterative formula, and you have to, like, manipulate this this equation in such a way that you make x the subject of this equation. Okay, so how he has done this, I think he has taken ln on both the sides, or you can start from here. You just go reverse and you show it equal to this equation. Okay, so let me use this here. So this is going to be, I'm starting with the cross multiplication, 2x, that is equal to ln, and this is 14 minus x cube, and then there is minus 1. I move this minus 1 to the other side. This becomes 2x plus 1, that is ln 14 minus x cube, okay? And then you move this ln inverse, will make it e raised to power 2x plus 1, and this is going to be 14 minus x cubed. So you have seen that we get the same equation. Okay, so the last part, that will obviously be iteration here. It says use an iteration process based on this part C to find this. Okay, it says give each iteration correct to 6 decimal places. So bachcho, what will be my iterative formula here? I'll be adding the symbols to the C part. He says use that C part. So I'll be writing this as x n plus 1, that is equal to ln 14 minus x n cube minus 1, okay, whole over 2. Okay, now what would be your x1?
0.5.
Yeah, that is 0.5. Okay, so I'm leaving this up to you now. You just show this step here, ln 14 minus, write this inside the brackets here. Okay, and then you have this 2 over here. Okay, so whatever that value comes here, you will use that to find that x3, and then this process you have to repeat, okay, to get to that required, like when it converges you will get that value. Okay, so use your calculator efficiently. Okay, but I'm just